We're talking about a sleeping Godzilla underneath Yellowstone that if it erupts in a maximum eruption called Category 8, it could literally tear the guts out of the United States of America.
Renowned physicist Michio Kaku has just issued a startling warning. A massive 100-foot wide crack has appeared near the Yellowstone volcano, with shivers of fear not only filling Yellowstone National Park but also resonating across the world. We are compelled to unravel the mystery behind this sudden occurrence. Does this abrupt development spell doom, or is it the result of a less consequential geological phenomenon? Stay tuned as we seek answers.
This restless Yellowstone caldera is truly living, breathing. Every once in a while, it burps.
Since its discovery, Yellowstone has always been a mysterious phenomenon that attracted the interest of millions. Park tourism has increased to over 3 million visitors annually from 2008 to 2021. The highest so far was in 2022, when the park had a total of approximately 3.29 million visitors. Several people have been interested in the park's various geysers and hot springs. As expected, there have been caution and safety precautions for visiting tourists and several observers. However, after the reported volcanic activity, there is even more reason to be extreme when navigating the awakened danger. Yellowstone is now popular for being home to a recently active supervolcano, about 1,000 times more dangerous than regular volcanoes. Before diving into the now open secret the park has guarded for centuries, let's look into the context surrounding Yellowstone Park. Like the theme of several other phenomena, Yellowstone was discovered in 1872 by John Coulter, a member of the Lewis and Clark expedition, and explored in pursuit of trapping and fur trading opportunities. The national park is a huge size of 3,472 square miles, the size of some states such as Rhode Island and Delaware. It has a lake that is 7,730 feet in northwestern Wyoming and the largest body of water in North America. Yellowstone is home to more than 500 active geysers, more than half of the world's. The Old Faithful Geyser, Morning Glory, and Midway Geyser Basin are the most popular. There are also over 10,000 hot springs, including Mammoth Hot Springs, Grand Prismatic Spring, Norris Geyser Basin, and more. Even more related to nature, Yellowstone has the largest concentration of mammals ranging over 67 species, such as the grizzly bear and its cubs, and about 285 species of birds, such as the rare osprey, can be found in the park. Let's discuss Yellowstone's hidden nature phenomenon. Beneath all the beautiful features and unique life forms in the park is a supervolcano that is not just dangerous to the locals, but is capable of devastating the Earth globally. Since its discovery, the caldera has been measured to be over 30 to 50 miles. The Yellowstone caldera has been measured to be about 3 to 10 miles beneath the surface and another 12 to 30 miles below ground. At first, it was thought to be like regular volcanoes, which hold more rock than liquid. However, since it is a supervolcano, everything about it is far from ordinary or predictable. According to scientists, the volcano holds more liquid molten rock, far above what was expected, and from previous predictions, the amount of melted rock beneath a volcano has been used to determine how close it might be to erupting. At the rate at which Yellowstone is going, with every increase, the rise in the liquid level shows it might erupt anytime soon. In brief history, the last eruption was about 700,000 years ago at the Yellowstone Plateau. Since its last eruption, about 30 rhyolitic lava flows have filled the caldera. Despite these mini eruptions being somewhat irrelevant or less dangerous, what makes Yellowstone the subject of scientists' concern is its implication. As a supervolcano, every seismic activity should be closely monitored to ensure every possible risk is noticed. The history of Yellowstone having super eruptions does not encourage anything less than high-level observation. To explain better, a supervolcano releases a volcano explosivity index, VEI, of 8 magnitude, very close to the highest a volcano can erupt. That is not all. It also has an ejection volume that spreads over 240 cubic miles of material on the Earth's surface. With its size, picture the terrifying volcanic eruption witnessed in the past, and imagine it more than 1,000 times worse. Even that might not cover how devastating the effect would be, and the even worse aftermath of the eruption. Due to the intense activities occurring beneath the ground, there have been several instances of increases and decreases in the soil level over the years. According to reports, from 1923 till the present, Yellowstone's ground has risen over 3 feet higher. However, it has also experienced ground-collapsing powerful eruptions that emptied the magma chamber. Between eruptions, the ground simply deforms due to rising and falling, caused by magma, water, and gas accumulation, and withdrawal from storage areas beneath the surface. From 2004 to the present, the ground rose by an inch. 2013, it rose to an unusually high 5.9 inches, the highest ever recorded. In 2010, Yellowstone's ground sank and was predicted to be the starting point of the supervolcano's preparation to erupt. The uplift and subsidence witnessed at Yellowstone now can be traced back to magma intrusion underground from 1996 to 2001, or, in the estimate, 20 years ago. That being discussed, the concern of everyone is how devastating the Yellowstone eruption would be. Let's discuss what to expect if Yellowstone eventually erupts as predicted. Let's deviate a little to the periodic, constant occurrences at Yellowstone. Yellowstone has been known to have a 500-year flood event. The latest occurred on June 13, 2022. Within a day, there were over 7.5 to 9.5 inches of rain and snowmelt in the northern parts of the park. Although the flood lasted for 24 hours, it lasted way too long in this case. It resulted in damages worth several $1,000s. Multiple sections of the north entrance road between Mammoth Hot Springs, Wyoming, and Gardner, Montana were destroyed, and 3 sections of the northeast entrance road between Lamar Valley and Cook City, Silvergate, Montana, were also severely impacted. Fortunately, due to proper management and recovery system, the park reopened 9 days after the flood after thorough measures were used to restore power, divert damaged wastewater systems, and help local communities with emergency response. All visitors and workers, with the aid of safety objectives, were all safe and accounted for within 36 hours. In 48 hours, there was successful restoration of power, diversion of damaged wastewater systems, and recovery plans being implemented. The impact of the flood was great damage despite being effectively curbed due to safety precautions. However, this is like a walk in the park compared to an active supervolcano eruption. In a recent report, the volcano has continued in its movement. Only this time, it is much more active than was ever recorded in the past decades. To support this is the record of Yellowstone's average annual earthquakes being over 1,500 to 2,500. The rate of earthquakes is very high. However, there are mini earthquakes, and 99% of those are magnitude 2 or below and can hardly be detected, nor are they harmful to visitors, workers, or humans. They are discovered by 50 seismometers, also known as Yellowstone Seismic Network, used to monitor the movements. As already obvious, the swarms of earthquakes and any dramatic and unprecedented uplift and subsidence of the caldera floor are used as evidence of the continuity of magmatic processes beneath Yellowstone and the possibility of future volcanism. Looking at past super eruptions, what similar occurrence would happen in the coming eruption? According to historical data, 3 extremely massive, groundbreaking, and terrifying super eruptions have occurred in Yellowstone for the past 2.1 million years. Each eruption has been periodic and known to occur within 600,000 to 800,000 years, with the last eruption having occurred 640,000 years ago. It left tons of volcanic ash debris that are very harmful to plants, animals, and humans, resulting in a 34 by 50 mile depression in the ground. Another term for the depression caused by volcanoes is called a caldera, and it occurs when volcanoes empty their stores of magma so fast that the overlying land collapses into the emptied magma chamber. The Yellowstone caldera is a sleeping or recently awakened hazard that was formed 64 million years ago and was followed by dozens of less explosive but large lava flows, the last of which erupted 70,000 years ago. The caldera takes up nearly 1/3 of the land area in the park. It has a more aggravating impact than the March 27, 1980, Mount St. Helens series of volcanic explosions and pyroclastic flows. The mountain's eruption led to the 75 meters crater explosion from the volcano's summit ice cap, eventually burying the snow-clad southeast sector with dark ash. About 520 million tons of ash were deposited eastward across the United States, resulting in complete darkness in Spokane and Washington, which is 400 kilometers from the volcano. Major ash falls also occurred as far away as central Montana and eastward as the Great Plains of the central United States. The dense forest, over 6.2 miles, was reduced to ashes, and over 230 square miles were destroyed alongside everything along its path. Worse still, over 57 people, including volcanologist David A. Johnston and photojournalist Reed Blackburn, were killed during the explosion. Despite the most recent eruption being thousands of years ago, there is still proof of its occurrence in the ecosystem at the Pitchstone Plateau, southwestern Yellowstone National Park. This is because the eruption 70,000 years ago consisted of rhyolitic lava and enormous amounts of volcanic ash, gas, magma, and other volcanic debris that covered most of the continental U.S., even as far away as Louisiana. Volcanic debris, also known as lahars, was found at the Lava Creek Tuff, where Yellowstone's youngest major caldera was formed. Lava Creek covers most of the western central United States. The volcanic ash was estimated to be about 660 feet thick, and over 300 cubic kilometers erupted in just a few days or years. The eruption at Lava Creek is periodic and known to occur every 600,000 to 800,000 years. These eruptions must be reported to reach a magnitude over 7 times more powerful than a regular volcano. There have been widespread coeval fall deposits, ignimbrite, numerous rhyolite flows, and domes that can be seen throughout the region. Lava Creek Tuff contains petrified wood from trees that died 50 million years ago during the eruption. Another recent supervolcano eruption was at Lake Taupo in New Zealand, where it last erupted 1,800 years ago, while the first was 26,000 years ago and, as a result, covered the central North Island with pumice and ash. Several contributions from the movements caused a mega eruption 74,000 years ago. During the eruption, it deposited tons of sulfurous ash over the major part of the central North Island area, especially east of Taupo, beyond Napier and Hawk Bay. The volcano released over 100 cubic kilometers of plumes of material into the atmosphere. It spread over 750 miles of ash to the land, inevitably transforming it from lush and green vegetation to creating Lake Taupo. This caldera was formed by over 700 small earthquakes and raised the volcanic alert level to 1 from 0. Let's discuss Yellowstone's super eruption. According to geological records, the average time between volcanic super eruptions or their constant recurrence is typically around 100,000 years. If this is how an eruption occurs, how will the Yellowstone eruption unfold? Based on past observations, the supervolcano eruption will be triggered by the movement of magma from deeper in the crust to the shallowest magma chamber. These movements will inevitably cause a swarm of earthquakes, ground deformation, and changes in gas or thermal emissions. As already discussed, these activities also serve as warning indicators for preparedness for possible future eruptions. Michio Kaku, an American theoretical physicist, warned that the Yellowstone eruption would devastate the U.S. and change the face of the planet. Its scale of destruction has great potential and is terrifying. Should the volcano erupt again, thousands of miles of the U.S. would be covered in volcanic ash, and the planet's climate would be altered as debris will be pumped into the atmosphere. A supervolcano eruption would have major effects on the global climate. Volcanoes emit sulfur aerosols that reflect sunlight into the atmosphere and cool the climate. These particles are short-lived in the atmosphere, so the effect is only temporary but can still be dramatic. The blast radius of Yellowstone is extremely powerful. Although it is impossible to accurately predict the magnitude of a supervolcano eruption, past eruptions have provided clues on how large the blast should be expected to be. The 3 huge eruptions that occurred led to the formation of 3 calderas and plummeted over 900 cubic miles of debris and ash into the atmosphere. An interesting piece of information is that Yellowstone can conveniently bury surrounding states such as Wyoming, Montana, Idaho, and Colorado in 3 feet of harmful volcanic ash. Also, the Midwest has chances of being blanketed by bits of ash, a less concerning level than the others. This means that all life forms, properties, and electrical outlets within these states are threatened by a danger lurking above them, playing God over their safety. All volcanoes have an expected lifespan, and Yellowstone, more than 4 centuries old, is seemingly at the end of its existence. Nevertheless, the impact should not be undermined. Regarding safety precautions, everyone within a 40 to 50 miles radius should be evacuated before the beginning of the eruption. The radius is confirmed to be within, as it is unlikely that any Yellowstone lava produced can go beyond this point. From the scientists' observation, climate and weather contribute greatly to the intensity of Yellowstone's eruption, and whether or not it will result in a small earthquake or an angry panther is almost entirely based on nature itself. The magma chamber below Yellowstone is being affected by 2 opposing forces. First is the heat welling up from below and the relative cold from the surface, and second is that if less heat comes in from below, then the chamber could conceivably freeze, eventually turning into a solid granite body. The average annual temperature of Yellowstone is only 36 degrees Fahrenheit, and on winter days, the air temperature is closer to below freezing. Also, the average amount of heat transmitted from the Earth's interior to its surface is 30 to 40 times greater. In contrast, cooler surface temperatures might alter dramatically the terrestrial and marine biosphere, necessarily impacting vegetation, especially tropical rainforests, and have at least a transient effect on the carbon and other biogeochemical cycles. If, as predicted, the supervolcano does erupt, it would have a drowning negative impact on the climate, such as the warming of the sulfur aerosol, which contains layers altering substantial atmospheric and ocean circulation and composition. It could also lead to large negative temperature anomalies at the surface, which could continue for decades. The most worrying of all supereruption effects is the drop in temperature, because while others can be recovered, the drop in temperature keeps causing harm until it is fully cleared. How? A history of the 1991 eruption of Mount Pinatubo recorded a temperature drop of 0.5 degrees Celsius from 1991 to 1993 due to 3 megatons of sulfur being released into the air. Another similar occurrence is April 14, 2010, at Eyjafjallajökull, Iceland. The eruption started in mid-March and extended months of increased seismic activities. Later on, the first eruption took place on the northeast flank. Volcanic ash over 9 kilometers was released into the atmosphere, and the eruption created a 3-kilometer-wide crater at the center of the volcano. After melting over portions of the ice cap, the summit crater emitted clouds of fine-grained ash that remained suspended in the atmosphere for long distances. Also, the ash blew over the Atlantic and directly over Europe. The tremor caused an immediate suspension of flights of most commercial aircraft for nearly a week in a controversy. It led to a temporary economic upheaval that caused billions due to the shutdown. Aside from economic devastation, some aftermaths almost scraped off agricultural productivity. In 1815, Mount Tambora experienced an eruption that released 12 cubic miles of gases, dust, and rock into the atmosphere and onto the island of Sumbawa and the surrounding area. The aftermath was more than disastrous. It was horrifying. About 10,000 of the island's inhabitants died, and the lava kept eliminating all life forms along its path. Plants, animals, vehicles, and buildings all perished during the explosion. A large chunk of the ecosystem was in shambles, and the soil was almost unrecoverable. There was widespread crop failure and spread of epidemics throughout North America and globally. It seemed like the end of everything. The dead were crushed brutally by an unstoppable force, and the living had to face an even worse plight as survivors. The Doomsday event was the reason for severe fictional and non-fictional accounts of the aftermath, the most popular being the Dr. Frankenstein monster introduced in the 19th century. The magnitude of a supervolcano is not limited to local risks, but also has global impacts. Yellowstone is a beautiful phenomenon of nature with the upside of being the worst nightmare of the human race. Although it has been debated severally that it is not capable of causing the global extinction of humans, the aftermath might have the living praying for the opposite. The eruption of a supervolcano like Yellowstone would not merely be a localized event. The release of colossal amounts of volcanic ash, gases, and debris into the atmosphere would have immediate and far-reaching global repercussions. The ash cloud could spread across continents, casting a pall of darkness that blocks out sunlight and disrupts the delicate balance of Earth's climate. A supervolcano eruption like Yellowstone's holds a little-known threat: a volcanic winter. Ejected ash and gases form a global cloud cover, reducing sunlight like an asteroid impact, causing cooling. Historic eruptions like Mount Tambora's in 1815 caused prolonged colder periods and famines, like the year without a summer in 1816. Yellowstone's super eruption would worsen this, with limited sunlight and disrupted climate causing severe crop failures, food shortages, and resource conflicts. The crisis could trigger global consequences. Sulfur dioxide and gases released during an eruption create sulfuric acid aerosols, potentially damaging the ozone layer and intensifying harmful UV radiation, affecting health, ecosystems, and marine life. Preparation is challenging. While monitoring Yellowstone's activity continues, predicting an eruption's timing remains difficult. Cooperation in disaster readiness is vital. Developing strategies, such as food security plans, global collaboration, and climate adaptation measures, becomes crucial to protecting humanity from the severe consequences of this rare but catastrophic event. Thanks for watching. Don't miss this video you see on your screen right now. It's unbelievable.